Hello, this is Brian Purdy with the Florida Aviation Network, live and in the clear from AirVenture 2025 in Oshkosh, Wisconsin. Today we're visiting with Michael Thompson of SkyFly, and then we're going to go look at the Axe aircraft behind us. And so, good morning, Michael. How are you doing today?
Very well, thank you. How are you?
Great. So, is this your first time at Oshkosh altogether?
It is. It's the first time the company's been here and the first time me personally being here, so it's pretty special.
Okay. I know we've had some difficulties with the weather and other things. Everything going well so far now and getting good traction with the visitors?
Yeah, I mean, we had some issues with customs getting it here, but we finally got it here on the stand. But yeah, no, yesterday was our sort of first proper day of selling and getting lots of interest. It's been great.
That's great. How long have you been working on this project?
So we came up with this sort of initial designs probably 5-6 years ago. They went through various iterations over sort of 3 years of test flying as a third scale versions we did. And then we finally locked down the final design about 2 years ago. The first airframe was built last year between sort of February to July. And yeah, that's what we've been test flying since October to now, really. We're still in the test flying phase. We've got a fair few hours on this machine now, so we're pretty happy with everything. It's gone really well. So yeah, the next phase is really getting into production and getting over here and getting a production facility set up as well.
You got a time frame on that? Year, 2 years?
Yeah, so we're by mid next year we want to have it signed off as a light sport in the light sport category in the US. In the UK we're going for a permit to fly. So these are 51% built by the owner machines with a build assist course with us at our facility.
Now one thing I notice about it I like is two-place. Are we looking at the recreational market first, maybe even eventually a commuter type use?
Yeah, so exactly that. We're not going after the air taxi market. We're very much set on being a vehicle that you own yourself and you use yourself to take you from A to B. So take off from your garden, go to the office, go to your second home, anywhere, go to a restaurant, a hotel. It's a sort of time-saving device. Don't get stuck in traffic. I mean, since being here in America, I can't believe some of the traffic jams you guys have. So it really makes it worthwhile having something like this take off vertically from your garden. It's unique.
Yeah, that's why I've always said I hate traffic, tolls, and potholes.
Exactly. Yeah.
So we will do a walk around a little bit later, but overall, how's Britain accepting this? Is it something brand new that they're saying, hey, maybe? Or
so the UK has been very supportive from a regulatory point of view. Civil Aviation Authority have cleared us to do test flying all the way up to transitions, which is fantastic. I guess the market in the UK is slightly smaller than the US. Obviously the US is a much larger country. That's really why we're focusing on being here at Oshkosh and getting the aircraft over here, because it's just a much larger market. I'd say the GA community here is much larger as well. Although we do have a fantastic community in the UK, it's just not as big. So yeah, we're really focusing on the US. We're also not only doing the version for a two-seat personal vehicle, we're also looking at an unmanned configuration, which is for defense applications as well.
So how big of a team do you have working on this right now?
So we're a very small team. There's about eight guys in the engineering team, and then we've got various sales agents. One in the US called Alta Sky. But yeah, we've always maintained the idea that we want to remain small as an engineering team, get the best minds. You'll meet Bill later, who's the chief technical officer. So we're a small, nimble team. We outsource some of the work to specialists. So for example, some of the composites, finite element modeling, etc., is done outsourced to specialist companies. So yeah, we're very much of the mind that the team is relatively small, just to keep the overheads down and make sure that we maximize the funding we've got to get this thing to market.
And easier to collaborate if you just knock on somebody's shoulder rather than have to, where is he?
Yeah, I mean, we want to avoid the sort of Boeing Airbus mindset where every department is separate. We have cross collaboration between the propulsion guys with the airframe designers, so it's really nice that way.
Now, I just saw this question. You mentioned the airframe. Is it carbon or fiberglass or?
Yeah, complete carbon composite structure. Bill will run through that with you a bit later. Yeah.
Okay, great. And now we're going to talk with Dr. William Brooks, one of the designers of the Axe. He's going to tell us a little bit about his history, some of the aircraft he's worked on, and why this is such a special one. Good morning, Bill. How are you doing?
Oh, all right, thanks. Yeah, it's hotter and sunnier than I'm used to back in the UK.
Now, is this your first time to Oshkosh?
No, I've been, I would think, about 2 or 3 times before. And I did demonstrate a flight design CT here on one occasion, brothers. Oh, plus. Yes.
Okay. So tell us about some of the other designs. I'm guessing they've ranged from small like this to larger and all carbon fiber, some fiberglass.
Well, my very first was a foot-launched canard layout aircraft with a chainsaw engine on, which I built for my final year project at Lanchester Polytechnic in Coventry. So flew that to my lecturer's house for breakfast, and yeah, I got a first-class honours from that.
Well, nothing like proving your thesis physically and all.
Yeah, I've always tested what I've designed. I think I owe it to myself to do that.
So when you started on this design, were there anything in particular that was, okay, this is our goal, and how it led to a specific feature or the design?
Well, I suppose the original layout came from Mikey Thompson and his father, and they had a small model prototype going. The thing I found interesting about it was the fixed 45-degree rotor angle on the tip, because the downwash from the rotor interacts with the tip vortex from the wing, and it increases the effective aspect ratio. So you get a bigger span wing than is actually physically there. And we think the effective span is more like from rotor axis to rotor axis rather than just wingtip to wingtip. And that's been borne out by quite reasonable low power requirement in the cruise with this. But it was one aspect that I thought, well, they'd done some initial CFD work or had some additional computer fluid dynamics work done, and that showed this effect. And I thought, aha, there's something interesting in this. But otherwise, it's some sort of conventional canard, and the power plant, the sort of resultant of all 4 rotors, acts through the center of gravity. So it is amazing on takeoff. If you use a lot of power, even as a conventional aeroplane, it's like some giant hand comes along and sweeps you forwards and upwards with no vibration and no noise. So yeah, it's a special experience to fly, that's for sure. And it's very easy to fly too. With the motors out on the tips, it adds a bit of roll inertia, quite a lot of roll inertia to it. So it feels more like flying a Cessna 172 in roll, rather than a little Vans or something like that. But on the other hand, it doesn't get bounced around by turbulence much because it's all kind of damped out by these inertias. So yeah, it gives quite a comfortable ride.
And I'm guessing you guys are using some simulator for flight training to see what it feels like before you actually climb in?
Oh yeah, that's been quite interesting. Well, very interesting. We're using X-Plane 12 as the basic simulation platform, which is very good. And we can also put what's called the hardware in the loop. So the actual flight controller we use for hovering, we put into the simulator. And then we can simulate hovering and then transitions in and out of hovering to fixed wing. So that's good. But what we...
So just going to run through the entire aircraft from the initial design phase. We wanted something that was aerodynamically stable in forward flight. That's why you've got these 2 large wings. It's a canard configuration. The canard on the front, the main wing on the back. So on the canard, we've got elevators to control pitch. On the main wing, we've got ailerons. So And then on the fin and rudder, we've got yaw control via pedals in the cockpit. So this means that if you have a full power failure, you can glide. It's got around 6-to-1 glide ratio. So that was a huge design consideration for us. We started off with a clean sheet design that could do the vertical lift by having wingtip mounted motors. So essentially you've got what looks like a quadcopter configuration. No, these are fixed pitch, so they don't rotate at all. So in order to get into the hover, essentially the front two motors will increase in RPM, so the nose will pitch up. Once it gets to its hover attitude, which essentially is from 45 degrees to horizontal, then the aircraft enters a vertical takeoff, and then you will transition forward again. It's all done via pitch of the fuselage, the transitions. So going into the propulsion system, we've got 8 motors overall. These are actually 2 motors in each housing. So you've got an outrunner and then 2 stators inside this motor. So that's for redundancy as well. When you walk down into the wing, you've got two inverters installed in the wing. Again for redundancy, so each motor has a separate inverter. As we walk down to the fuselage, inside here we've got 8 batteries in the front, 8 batteries in the rear of the aircraft's fuselage. So 4 batteries power 2 motors. So again, one single motor has 1 inverter to itself and 2 batteries. So as we walk around, let's have a look what else we can talk about. So the undercarriage configuration is a tricycle undercarriage, which means it can taxi around, nose wheel steering, so it's very, very easy to move on the ground. Let's walk over, actually let's go around this way. So as I said earlier, the aircraft is mechanically actuated, so all these control surfaces you see here, they're mechanically actuated through a center stick in the cockpit. So if you look back behind you, or if you film me doing the roll, so you can see the ailerons moving at the back, and then on the canard you've got pitch control via the center stick in the cockpit. So if you want to just quickly, so this is roll, pitch, and then down there you've got the pedals.
So it's controllable or flyable from either seat?
Yes.
And it's just the one seat that's going to have the instruments, or?
Yeah, so pilot's generally on the left hand side.
Okay.
But it is flyable from both sides. So yeah, the pedals run to this large fin and rudder. Again, it looks massive, but it's because we needed complete directional yaw stability, because it's quite a short machine, which we needed to have for the vertical side of things.
The slower you're going, you need to catch it.
Yeah, exactly. So there's brakes on the main gear, so it's not directional braking because you've got nose wheel steering. But yeah, Behringer system on the main undercarriage. 4-bladed fixed pitch propellers from E-Props, which are really nice. I mean, one of the main things we've found with this machine during test flying is just how little vibration we get out of it, and how quiet it is inside the cockpit.
It's a big fish, you got cup holders.
Yeah, you could just balance a cup on this thing. Yeah, so this aircraft's been designed so it can do both the conventional fixed wing takeoff, but also vertical takeoff. And in between those, you have an incredible stall capability. With the 45-degree angle, you've got not only the wings giving you lift, you've got an element of thrust coming from this angle. So it's very, very capable. 280 kilowatts peak power available to you, which means you take off incredibly quickly in a stall configuration as well. But generally, if you're doing a vertical takeoff, you're basically trying to escape the dead man's curve as quickly as possible. So as soon as you can get forward speed up, as soon as you've cleared your obstacles, you're looking to push the nose forward and build up airspeed. So it's very much like a helicopter in that aspect. And yeah, generally if you're doing a conventional takeoff, you use a lot less energy. So in the hover, it uses around 200 kilowatts to hover, and then in forward flight you're only using around 50 kilowatts. So it's a massive difference, and that's thanks to the wings. So this is Dr. William Brooks. He's the Chief Technical Officer, is the designer of this aircraft. So we're going to, and he's the test pilot as well. So I'm going to hand it over to Bill, and he's going to run through some of the more technical aspects of the structure of how we've made this aircraft so light.
Oh, hi there. So just describe the airframe a bit on this SkyFly Axe. It's really using technology similar to gliders. It's an all carbon fiber airframe, and it's quite quick to rig and de-rig. And you could consider it like being a pair of glider wings. So each wing has got a spar that projects across to the other side, and the spars overlap so that the spar on the right wing is further forwards than the spar on the left wing, which keeps the spars straight. They overlap, and then there's two pins, spar pins that go in, and then there's each side there's two root pins as well. The difference being, I suppose, that with the high thrust forces right out on the tip, as well as the upward component, you've got a forward component as well, and that's why you need a pretty strong shear pin on the rear root pin connection, because you've got 440 pounds of lift force going up through the rotor.
Total for the aircraft?
No, that's each. So you've got to get a thrust to weight ratio better than 1-to-1, of course.
Okay. Yeah, so I was going to ask.
Otherwise, you're not going anywhere vertically.
Yeah.
So yeah, there's a single main spar. It's a carbon sandwich skin. And then out here there are two ribs.
Now, are the
Yeah, I mean, as far as the pilot is concerned, there's no real difference. If you're doing a conventional takeoff, it's very similar to any other canard in that, or virtually the same as any other tricycle undercarriage airplane, in that you want to get the weight off the nose wheel as soon as possible. So you pull back on the stick, get to about 42 knots if you're doing a conventional takeoff, and the nose lifts off, and then you trim out at about 50 knots. If you use full power, if you use the vertical takeoff type power, then you're climbing at well over 2,000 feet a minute. It's quite incredible. And it's quiet and it's smooth, so it just feels like you're being propelled upwards by some giant hand or something. And the view out is good too, so it's a nice experience.
So, Michael, we've got a prototype over here, but production's going to be a little bit more beefed up, more capable. Tell us about what we should expect when we go to buy one.
Sure. So on this aircraft in front of you, we've got a quite low voltage system. So we're going to increase the voltage between 400 and 800 volts. We're not finalised on that. We're also changing motor supplier. So we haven't announced who that is yet, but it's going to be announced soon. So the motor will have an inverter built into the back of the motor, so we won't have this inbuilt inverter in the wing situation, so it'll be much simpler to rig, much simpler to build as well. And then the batteries, we're going from a low voltage system to a much higher voltage system, and we're also increasing the capacity to 60 kilowatt hours from 50 kilowatt hours. And the energy density, what we got here is around 200 watt hours per kilogram, and we're going up to 270 watt hours per kilogram. So that's taking advantage of newer cells. You know, when we were designing this, there were cells available, but since then it's come quite a long way.
What do you expect the final version, the recharge time to be? So you know how much time you need to wait before you can do the next leg.
So it depends on the charger you've got, but generally we've partnered with a company called AirVenture, and they make a 45 kilowatt charger. So roughly, and that's at 450 volts. So you'd be charging in about an hour and 20 minutes, something like that.
We'll look forward to seeing the versions as they develop. I'm guessing just go to the website to keep the most up to date.
Yeah, so our website's www.skyfly.aero, and from there you can reserve an aircraft, look at some of the more specs. There's an FAQ section, all sorts. But yeah, really, we'd love to get some more orders in. So if you're interested, it's only £1,000 reservation fee to get on the list to be a customer.
Great. Well, thank you, Bill and Michael. This is Brian Purdy with the Florida Aviation Network, live and in the clear from AirVenture 2025 in Oshkosh, Wisconsin. Have a great day.